lots of students had problems with this question. And a number of them tried think or thought that maybe they would use negative powers to rationalize. And you don't. What you want to do in order, when the power is greater than the index, which you know isn't part of the simplified form, you need to simplify it. So we're looking to remove perfect or any powers of 2 that we can. So before we rationalize, if you were to take the square root of x cubed, that would simplify to what? What could you remove from that? It would simplify into x root x, right? Well, it's the same idea, except instead of x, your base happens to have these 2 factors, a 3 and an n, but it just treat it as a single base. So 1 3n comes out, and that leaves 1 inside the radical, and now you can go through and rationalize with the same rules. Right? You only have to worry about the radical portion of it, not the other 3n. And in fact, this 3n can actually cancel and reduce. 3 goes into 12 4 times. And so now when you're looking at rationalizing this, you're going to multiply by the same radical, square root, the same base, 3n. And you need a total number of those bases. Again, remember we're using the entire base 3n. If you need to put parentheses around it to help identify that, you can. Okay, but how many 3n's do we need to equal the total index, which was 2? We had 1 to start with, so how many more do we need? Just the 1. Okay, so when we multiply across the top, we get 4 times the square root of 3n. And when we multiply across the bottom, we have this original n. Then we have, again, square root of a base times the square root of the same base gives you the square root of that base squared, where the index and power are the same, so they cancel. You can just extract your base 3n. Okay? And then the last part to simplify this is to just multiply. And remember, when you multiply here, you're not adding coefficients. Again, these would be exponents, so you're multiplying exponents with the same base, so you add their powers. Power of 1 gives you a total n to the second. So you get 3n squared for your denominator.